My name is Ondrej, and in this video I'll teach you how to fine-tune Llama 3 so that it performs 10 times better for your specific use case. Let's start with what even is fine-tuning, and I made this explanation in plain English so that anybody can understand. Fine-tuning is adapting a pre-trained LLM like GPT-4, or in this case Llama 3, to a specific task or domain. It involves adjusting a small portion of the parameters on a more focused dataset. So, when a new model releases, what everybody needs to know is how many parameters it has. We have Llama 3 8B, and always that number, like 8B or 70B, that's the number of parameters. So we're adjusting just a small number of them to make it more focused on a specific thing. Fine-tuning customizes the outputs to be more relevant and accurate for your use case. Here is the power of fine-tuning. Cost effectiveness. It leverages the power of pre-trained LLMs, which cost tens of millions of dollars, if not hundreds of millions, to train. And we can just, run a GPU for a few hours and fine-tune something for, I don't know, like cents, a few cents or a few dollars at the most, which is just amazing. It gives you improved performance because you can enhance the LLM on your dataset and improve accuracy for specific tasks. And it also is more data efficient. You can achieve excellent results even with smaller datasets. So, maybe even like 300, 500 entries, while, Llama 3 was trained on 15 trillion tokens. I don't know about you, but I don't have nearly as much data as Zach. So that's why fine-tuning is great for people like you and me. So how does LLM fine-tuning actually work? First, you need to prepare your dataset, and this, depending on how hardcore you want to go, this can take anywhere from 20 minutes to a few hours to weeks, potentially. Depends how far you want to take it. So you create a smaller, high-quality dataset tailored to your specific use case and label it appropriately, which I'll teach you in a bit. The pre-trained LLM's weights are updated incrementally using the optimization algorithms like gradient descent based on the new dataset. So we can only fine-tune LLMs that we have access to the weights, meaning open source, open weights LLMs. You cannot fine-tune GPT-4 if you are not OpenAI. OpenAI can do it, obviously, but me and you, we probably don't have GPT-4 just laying on our computer. Then you monitor and refine. You evaluate the model's performance on a validation set, preventing overfitting and guide adjustments. Now here are some real-world use cases for fine-tuning. Fine-tuning an LLM on customer service transcripts can create a chatbot like this one that can address issue in a way specific to the company. So let's say, you have a specific product, very niche, that there is not much data about it on the internet. And if somebody messages your customer support email, you want your, chatbot to respond in a specific way based on the information of your product. And that data is proprietary. It's private. Only you have it. And you can fine-tune an LLM to respond based on that data. So technically, if you have enough scripts, you can fine-tune an LLM to respond like you. And if you try ChatGPT, if you even give ChatGPT some writing and tell it continue in this writing style, it's terrible. So this is where fine-tuning could be better. Tailored content generation. So you can fine-tune an LLM on your posts and descriptions to create engaging summaries or marketing copy, again, in your writing style, tailored to your audience. Domain-specific analysis. So fine-tuning LLM on legal or medical text can make it much better for those specific benchmarks. So you might have a model that, let's say it reaches 50 on some arbitrary benchmark. With fine-tuning, it can reach 70 or 80. Now let's dive into how to actually implement this on Llama 3. So I created this Google Colab. Well, actually, most of it was created by Anslof team. A huge shout out to Anslof because they did all the heavy lifting. So I'm going to also link their GitHub below. Now, first off, I added a component that's only available in April to the community. So if you join during April, you will get a personalized AI strategy to future-proof yourself and your business. So if you want to be among people who are building the future, if you want access to all the different courses, modules, and everything else in the community, and to 2 weekly calls, then consider joining. And especially if you want me to give you a personalized AI strategy to future-proof yourself. So if that sounds interesting to you, make sure to join the community. It's the first link in the description. Now let's fine-tune Llama 3, shall we? So first thing, we check the GPU version available in the environment and install specific dependencies that are compatible with the detected GPU to prevent conflict. So this is this cell. By the way, if you don't know how Google Colab works, which is, you know, the software I'm using right now, it's super simple. It's basically splitting the code into cells. It's called the Jupyter Notebook, but it's like much more easier to see. You can add text, you can add graphics, and it's great for like tutorials and explaining, right? So if you never use this, it's great because it's free and Google actually gives you a GPU, so you can use this T4 GPU to train this model for free. And but if you want faster, you can obviously upgrade it, right? So I'm gonna link this Collab below the video as well. So we run this cell, which does what I just explained. The next cell, we need to prepare to load a range of quantized language models, including the new 15 trillion Llama 3 model, so trained on 15 trillion tokens. And it's optimized for efficiency with 4-bit quantization. I mean, I'm not gonna even pretend I know everything about fine-tuning because I don't. So if, you know, if it seems like I have gaps in my knowledge, it's because it is. I do have those gaps in my knowledge. So I try to make it as simple as possible. But if this proves something, it proves that you don't have to be a machine learning expert to fine-tune models. So, you know, just follow along. So here, this is the max sequence length. Obviously, Llama 3 is up to 8,000. So, I mean, 2,000 is plenty for this demonstration, but you can do anything. You can do 4,000 or 8,000. Here, use 4-bit quantization to reduce memory usage, but it can be false as well. So here are the models. We can see like we have Mistral 7B, Llama 2, which is the old one, Llama from Google, but obviously we're interested in Llama 3 8B. And by the way, we can also use Llama 3 70B if you want, which obviously will take longer because it's a much bigger model. So in that case, you might want to buy the premium version of Collab or just wait for a while. But yeah, I mean, everything is the same. Just here, you would change the model to Llama 3 70B. And if you want to use like a gated models from Hugging Face, which gated means that you have to usually agree to some, you know, license or whatever, then here just remove the comment and then put your Hugging Face token here. Super simple. Now, by the way, you always have to run this. So what you do when you go to Google Colab, you click on runtime and click run all. That way all of the cells run. But you can also do it one by one by clicking this button right here next to each cell. And it needs to have this little tick, green tick. That way it was executed. Here it's not because I, you know, removed the... I changed this. So anytime you make any change, it disappears. But that doesn't matter. It was still executed. So it's stored in the runtime. Next up, we integrate LoRa. Again, you don't have to understand what this is, but it's basically a way of fine-tuning into our model, which allows us to efficiently update just a fraction of the parameters, enhancing training speed and reducing computation load. So again, we're not training the model from scratch. We're just fine-tuning a few parameters for our specific use case. And here you can change the R to any number greater than 0, 8, 16, 32, 64, up to you. And your goals, what you want to do with it. By the way, Unsloth, the reason I'm using it is because it makes fine-tuning much faster and consuming less memory. So it's actually a great framework for this. Data prep. We now use the alpaca dataset from Llama, which is this one, which has 50,000 rows, and I have it loaded in VS Code here. Just that way you see how it looks like in JSON formatting. So, you know, it's a lot of lines because for everyone it's basically times 5, yeah, so like 250,000 lines. And it's like every one of them has an instruction. Should probably zoom it in. Okay. So yeah, every one entry has an instruction. Give 3 tips for staying healthy. Input, this is not mandatory because instruction is already enough context. And then output, this is what the LLM should say. And you do this enough times and the LLM, you know, learns. It basically learns, right? So we can see it probably better here. And if you want to use your own data set, you have to format it the same way. So, you know, just having output, input, and instructions, these 3 parameters. But yeah, just look at this. Not all of them have the input, which is fine. I mean, probably like 20% or 15% have the input, and that's just extra context. So yeah, I'm also gonna link this data set below. But if you want your own data set, which, you know, if you want your own use case, just make sure to format it this same way. So, you know, instruction, some text, input, some extra context or empty, and output how the model should respond. And, you know, if you're getting creative, you can definitely use LLMs to generate these large data sets much faster. I mean, maybe you create really like 20 high quality examples by hand, and then you run a team of agents for creating that data set that can just, you know, use those 20 examples to create 50,000 like in this data set. But yeah, that's a topic for a whole nother video. So if you want me to make a video on how to make data sets for fine tuning, then let me know. But let's go back to our Collab. So then we define a system prompt, which is, you know, custom instruction system prompt, which you already know, hopefully, that formats tasks into instruction, inputs, and responses. So this has to fit with our dataset. And we apply it to our dataset for the model, and we add the EOS token to signal completion. So this token right here we define it, and here we add it, because without this, the token generation continues forever. So we don't want that, obviously. So let's look at the system prompt. It's very simple. It says, below is an instruction that describes a task paired with an input that provides further context. Write the response that appropriately completes the request. And that's our system prompt. And then we feed it the instruction, the input, and the response. And obviously you can change the system prompt if you want. Now, train the model. We do a 60-step, we do only 60 steps here to speed things up. You can, like, this is obviously very small because it's not even one epoch, training epoch. So if you want to like actually use something for production or your business, you probably want to train it for longer than 60 steps. And I'm going to show you how in this bit. So if you do multiple epochs, you have to turn max steps none. So here, okay, number of trained epochs is not included in here. So what you would do is you would copy this, and you would go in here and look at the steps, right? So we have the steps here. You would add this. Maybe you would do 4 or whatever, however many you want. The more the better, but at a certain point it starts to not yield better result. So max steps, you have to change it to none, right? So it's like 60 right now. So you do none, and this is where you would do like proper fine tuning. But you know, I just had it at 60 for demonstration. That way it's faster, and it still took like 8 minutes. So I'm not gonna replicate it. I'm just gonna show it everything. But yeah, basically, you know, this is what you do. You decide how many epochs you want, and then at this stage we're configuring our model's training setup, where we define things like batch size and learning rate to teach our model effectively with the data we've prepared. So obviously you can like mess with stuff here. Again, I'm not gonna pretend I understand everything, but the main things are, you know, packing, like this can make it 5 times faster for short sequences. Obviously the steps and the epochs, but yeah, I mean, if you're confused something, just take a screenshot, boom, like this, and ask ChatGPT. Now, this is the current memory stats, right? So we're using the Tesla T4 GPU provided from Google for free, and the max memory is 14 gigabytes. And this is where the training begins. This is the magical part, right? So here we do this line of code, trainer stats, trainer.train, and this will give us the statistics as the model trains. So again, this is only 60 steps, which is like 0 epochs, but yeah, you can see the training loss going down. So like basically smaller number is better here. So you can see like at the start we have 1.8, 2, like 1.9, and then it quickly starts dropping to like 0.9, you know, around 1, 0.8. So it fluctuates a bit, but it consistently goes down, 0.7. But you can see it's reaching like a asymptote, right? Obviously it's only 60 steps, so it really doesn't mean anything. But yeah, like we ended up like 0.8 from like 2. So it shows you like if the model is actually improving. And this took like 8 minutes. So you can see the stats here, right? So 476 seconds, almost exactly 8 minutes. Peak reserve memory was 8.9 gigabytes. And for training was 3.3 gigabytes. So not Like this is the power of Unsloth. It's like really optimized for this to use, to run faster and to use less memory. So that way we can fine tune GPUs for cheaper. I mean, you know, I'm using a free T4 GPU from Google, so it's free, but it's faster. Like if you didn't use Unsloth, it would be a lot slower. So, okay, so 60% of, we used 60% of max memory, so that's good because we didn't like hit the limit. So we still have like 40% reserved. And for training, it was only 22%, which is even better. Inference, which means here we actually run our new model that we fine-tuned. And okay, so this data set is for like instructions. And this is basically when you see a model that has like instruct at the end of it, this is what they mean. It's just trained on a large data set of instructions. Because usually the models are more for like chatting, for text generation, you know. You give it some input and it's like, gives you some output. It's, you know, for more conversational. Here for instructions, for the instruct models, it's to follow instructions. You give it a task and it completes it. So like we can see it probably here in VS Code, like rewrite the sentence to change its meaning and then output the thief escaped compared to data sub. So this is like all tasks, it's all in instructions, and then it shows how the model should do it. So let's look at it, right? So now we've trained the model. This took like 8 minutes to do. So all of you can do this. The beauty of using a Google Cloud is that obviously it doesn't matter what machine you have. Even if you have a terrible computer, this will take the exact same time because you're using the GPU in cloud. So obviously here you can change your prompt. I mean, this is, you know, I changed the prompts here. So this is my prompt, but always make sure to leave the output blank. So here, the first one is the instruction. Then this is the input, like the extra added context, and the output, leave it blank because the model will generate it, right? So list the prime numbers contained within this range, and then the range is here in the input, 1 to 50, and then the model, our new fine-tuned Llama 3, generates the output. So let's look at this. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and just by looking at it, you can see it's correct. I mean, none of these numbers are divisible, so yeah, this is correct. All of them are prime numbers. And also this is even better. Like I think this is much more visible, using text streamer for continuous inference. And I'm just gonna show it again. By the way, this is how it looks, right? So you have the instructions, it's separated, but that's not the main thing. Not only is it formatted better, it's continuous inference. So you can see the token generation token by token instead of waiting for the whole time. So if I run this, as you can see, it waits and it generates it all at once, right? So boom, it like appeared all at once. So if you want to see it token by token, this is much better, right? And look at how fast it is. This is the power of Llama 3 8 billion. A small model, but a very capable model. So yeah, text streamer is great for this, and you can see it how it's generating the answer. So yeah, this is the next prompt I used myself. Convert these binary numbers to decimal, and then here. And by the way, again, you can use these prompts like example, create like 20, 30 by hand maybe, and then, you know, feed these into ChatGPT or your team of agents, something automated ideally. Or I think there's a service for like reflection AI or something like that. But yeah, either way, you can, creating large data sets needs to be automated, right? So you cannot do that by hand. But either way, like you create something like this, so these examples, and then you would feed that into your own data set, obviously relevant to your use case, to your business, and you just go crazy and create as many as you possibly can. So like really at least 1,000, like this is 50,000 and it's still probably could be larger. So yeah, I mean, you have to, again, that's probably another video to build a team of agents to generate data sets. But yeah, okay. So here we give it 3 different binary numbers, and its tasks is to convert it to decimal. And as you can see, it does it flawlessly. I mean, this is 10, it's 13, 15, that is correct. So we have the model, we tested it a bit with 2 prompts. Now it's time to save it. And because, you know, we spend all this time, all this GPU power training it, we don't want to go it to waste, because if you restart the runtime in Google Colab, your model will disappear. Obviously you can run it again, but then you have to wait again and, you know, maybe run out of the free GPU hours. So to save the final model as LoRa adapters, we can either use Hugging Face push to hub, for an online save, if you wanted your model listed on Hugging Face, so Hugging Face lists datasets and models, is probably the main two things it's used for. So if you want your model shared, then you would do that. But if you want it just saved on your computer, do saved pre-trained for a local save. By the way, this only saves the LoRa adapters, meaning basically the things that were changed. It doesn't save the entire model with the change parameters, just the changes, right? So it's less memory and yeah, just faster to save. So, but if you want to save the LoRa adapters with the saved model, you can change this. If you want to load the LoRa adapters we saved for inference, you would change this false to true. So simply changing this. And yeah, this is the model name, so obviously you can change this. This is your model used for training. Here is just LoRa model, but you can name it Llama free, I don't know, copywriting, or Llama free medical diagnosis, whatever your use case is, obviously. And then here the alpaca prompt. So yeah, this is the variable we declared earlier. So this is the importance. You cannot just go into the Collab and try to running this cell. You have to run the cells from above. Otherwise this will not work. So whenever you're using a Jupyter notebook, such as Google Colab, always run all cells in order. Otherwise it will not work. So yeah. So this is the same format, right? From earlier instruction, input, output. At this point you should be familiar with this. And that's just for this particular data set and for this style of prompting. So if you have a different one, then follow the different one. So obviously here, what is the famous tower in Paris? Obviously it's Eiffel Tower, blah, blah, blah. It gives some extra info about it. So you can also use Hugging Face auto model for a perf casual LM, but Unsloth does not recommend this because it's a lot slower than Unsloth. So yeah, if possible, use Unsloth for speed. And as the name suggests of, Unsloth, it's unslowing everything. It's making everything 2 to 5 times faster. So why not do that with 80% less memory? So yeah. Okay, and then we're preparing to save our trained model in a more compact format and then upload it into a cloud platform, which allows for less storage and computation power. So again, like, I'm not gonna even pretend I understand everything, because this is honestly stepping outside of my comfort zone, but like just building this and doing this fine-tuning taught me a lot. So if you want more technical videos like this, let me know. Next, we're ready to compress our model using various quantization methods, which means just, making it easier to run on a machine. So maybe you cannot, like if you have a bad computer, maybe you cannot run the full model, but you definitely can run a quantized version of it. It makes it leaner, and then we upload it to the cloud for easy sharing. And this is what this piece of code does. And so we use the model unsloth.gguf file or the quantized version, so the Q4 means quantized, in Llama CCP, or if you want a UI-based system, which probably you do, which is easier to use, you can use like GPT-4 or this is the other one, it's escaping me, but yeah, these are basically these UI-based systems that you can use to, or LLM anything, yeah. I don't know if this supports it, but yeah, basically these frameworks have a UI that's easy to chat with, and you can use open source model there. So if you fine-tune this, you can upload this to GPT-4 and chat with your own model very easily. And yeah, that's it. You know how to fine-tune Llama 3 for your own specific use case. Again, I'm gonna leave these resources below the video, and if you have any questions regarding to Unsloth, join their Discord. So yeah, that's it. If you find this useful, then please subscribe. And again, if you want, during April, which is what, like 8 days, 9 days left, if you join the community, you will get a personalized AI strategy to future-proof yourself and your business. So if that sounds valuable to you, then make sure to join. It's the first link in the description. Thank you for watching.